everyone, welcome to another tutorial. This one is going to be in Godot, which is becoming my editor of choice lately, my game engine of choice. This time we're going to do a bit of endless terrain generation using threads and also generating the collision shape that allows us to basically navigate this terrain. And as you can see, as we move along, the terrain gets generated in front of us and it gets deleted from behind us. So this is basically a grid system where we have like 9 chunks, the one in the middle plus the 8 around it, and these chunks get generated dynamically as we move from one chunk to another. And it's basically using Perlin noise to generate this and also to generate the collision shape. So let's get started. I'm going to move back to our project list, and I already started an empty project basically. And let's see, we are going to start with a spatial node as our root node here, and I am going to quickly add a bunch of stuff here. I will need a directional light, and we're going to call this our sun. I'm just going to move this out of the way somewhere up there, and I will probably rotate it a little bit just so it kind of illuminates our objects as we want. So good values for this, I could have just put it up there so I don't really see it. And let's put 45 degrees here and about 180 here. And that should give us some good illumination for our objects. Next up, I am going to create an empty node. Let's call it a spatial. It can be a spatial, I think. I'm just going to call this terrain generator. This is going to be the object where we're going to generator, where we're going to attach our script to generate the terrain, basically. Next, I am going to add a mesh instance that is going to be our fake floor, just for reference, or just want to see something here. So I'm going to basically set this to be a plane mesh here, and I'm going to give it some transform information. Let's say minus 0.7 here. Oh, not 0.7, 0.7, just so it's like 7 centimeters below the 0. And let's scale this up to 100 by 100 so we can, see something here. I also want to give it some material just so it's not so bland. So I'm going to do a new shader material, I guess. And I'm going to make it a visual shader, sure, why not? And let's edit the shader for this. I'm just going to drop in here a small texture for a grid, and let's drag this in, and let's put RGB here. And then I think I also want to scale a little bit. Let's see. Yeah, I think I'm gonna take the input here. Oh, the input. I'm gonna take the UV input. I am going to do a vector up, which is going to be a multiplication. I'm going to multiply by 200 here, and I'm just going to set this as the UV. So this means that it's really, well, maybe that was too much, I think. Oh, I get the coordinates wrong, so sorry about that. Yeah, that looks much better. So it should be roughly 1 meter. Each cell of these should be roughly 1 meter. So going back, we have our floor now. Let's see what else do we need. We need a player, but first I'm going to add also like another mesh instance, and this time I'm going to make it a sphere maybe, and with less let's see, less ones. Oh, here, with less geometry. So I am going to make it 2.5 by 5, and here I'm going to do 12 by 6. This is going to be like a rough kind of sphere, just so we can see. I'm going to give this terrain like a flat shading kind of thing, so this is just going to help me see if the material for the flat shading is okay or not. And I also want to change the transform a little bit here. I'm going to move this to 0.7 on the X, and well, this can be 0 actually, it doesn't really matter. Or I'll just move it like 2, just so it's not in front of our player when we start at 0. And here I'm going to put it at 3 and -2 or something like that, just so it's not directly in the origin when we start having our player inside. So now I want to give it a material, and this is going to be the material that I'm going to use. I'm not going to spend a lot of time with this material. I'm just going to copy it from where I already have it. I can give you a brief explanation of how it works, but yeah, I'm just not going to spend a lot of time with this. Let's see. I'm just doing this off screen to copy the material to this project, and it should be here now. And I'm just going to drag this in here, and we have like a flat shading kind of thing. I can show you the exact visual shader. So this basically does a derivative on the x and y vertex coordinates. There's a cross product between them, normalizes, and that applies it to the normal. And that's basically how you can achieve like a really simple flat shading thing. And I think I'm gonna drop the energy of the sun a little bit, because I think it's too high and it's kind of messing this up. So 0.2, yeah, that looks much better. So the sun is there, light, dark, perfect. So now that we have this setup, I am going to create the player, and the player is basically going to be a kinematic body. So let's just add that in. This is going to be the player, and the player is going to need, let's see, it's going to need a body, just for reference. So this is going to be a mesh instance, and it's also going to need a collision shape, and the collision shape, that's fine, I'll change this later. And I also want a camera, just so we can track the player around. So the mesh instance, I'm just going to set it as, let's see, a cylinder, no, capsule, which is pretty standard for most games to use a capsule for the collision shape. I'm actually using it for the mesh, but that's okay. It's just for, you know, reference. I'm going to rotate this on the x-axis, and that's fine. I'm not going to touch it anymore. The collision shape, I want to say capsule, but I had some problems with the player dropping off from the collision shape of the terrain in the past, so I'm just going to set it to, you know what, I'll just leave it as a capsule. So moving on, the camera, I want to move the camera a little bit further from the player, just so we see it. So let's move it to 12, 15 here, so basically a bit higher. And what am I doing? Yeah, and let's put some rotation here as well, and 9 degrees here. So in principle, this camera should be pointing down towards our player. Cool. We can also, I think we can also make this camera the current one, which is, it's not required, but it's fine. So let's save this. Let's save this as our scene. It doesn't really matter what you call it. I'm just doing this for the tutorial, so I'll just call it scene. You could call it, I don't know, level 1 or whatever you want. So now we're going to right click here on the player, and we're going to do save branch as scene, called player, just so this is instanced into our scene and it's now its own thing. So if you click here, you have the scene for the player, and the scene has the player inside. So let's run this. Let's select the main scene as our scene. See what this does. Okay, we're looking down. It looks okay. So now we need some way to move the camera. I also have a script to move the camera. So I'm just going to attach a script here. And let's call it camera, sure, why not? And I'm just going to copy paste inside. This is a simple script for the rotation of the camera. Feel free to take a look at it. If you are interested, you can set the mouse sensitivity here, and basically it has a reference to the player, which is its parent, kinematic body, and then basically captures the mouse, and whenever you rotate, it basically rotates to one place or the other. And that should be enough to give us some motion on the camera. Let's see. Yeah, sure enough, we can orbit around the player and we can move a little bit up and down. Cool. So next up, let's see. Our player also needs some. Oh, let's set up the inputs first. So here in the project settings, we need to go to input map, and we need to add a bunch of new inputs here. We're just gonna say we're gonna have a forwards, so we can move forwards. We're gonna have a back, a left, a right, and a jump. Why not? And let me just quickly assign these here. Okay, we should be set. Our keys are set, so it's all good. Let's see what we want to do with the player. So I want to add a script here. I'm going to call it player, and this script is basically going to control the movement of our player. It also does stuff like rotating the player forwards and jumping, moving, and applying gravity, sliding along where you're going to be. Yeah, so it should be good as a starting point. So let's see if this works. Oh, we broke it. Index rotation, body. Oh yeah, we need to call that body instead of mesh instance. I forgot to rename this guy because we're referencing it inside the player script. So okay, it's good. We're falling through the ground, but that's okay because our fake floor does not have a collider, so that is basically why. We can just add a child node here, static body with a collision shape, and we just do like a plane shape or something like that. Maybe we actually transform it to roughly the same size. I think that's too much. It's probably 10. No? Yeah, that's too much. 6, 5. Oh, needs to be half of the actual size. Wow, I have no idea what this does. Let's say 5. 5 seems to be bigger than what we actually need, so yeah, let's try that. And let's press save. Oh, we're gonna fall because we're inside the ground. So let's just move the player up a little bit, just so we see actually gravity starting to occur. And yeah, sure enough, we're here, but we're not moving. So something is wrong here, and I'm going to check why. Okay, so I figured it out. We shouldn't use a plane shape. It actually it says that it works really poorly, and it's going to be removed actually in future versions of the engine. So don't use it. And I did use it. So let's just change this to a box shape, and now we should be able to move around. Yes, okay, we can move and we can also jump. That's fine. Cool. So let's move on to the actual generation of the terrain. So let's see what we need to do. Our terrain generator needs a script, right? We said we would do it here, so let's attach a script here. And I'm going to call this, sure, terrain generator. Why not? Let's just remove this. Let's see what we need to do. So first things first, I'm going to declare the function ready here. And I am going to create a variable for our noise that we're going to need. And I'm going to randomize our noise with a bunch of variables. You can tweak these to generate the terrain as you see fit. I just did it like this, and gives the results that you saw. So now things that I need to keep track of all the threads that I'm going to use for the terrain generation. And I need to track the chunks that are generated already in the scene. I also need to track the chunks that are being generated, just so I don't repeat generating the same chunks by accident in case they're already generating and they take a little bit of time. I also want to set up the material for our terrain. And what else? I need to track our player and also our position in the grid. And yeah, I think that's pretty much it. So the way this is going to work is I am going to constantly keep track of where the player is in terms of grid. Let's say like the first chunk is at 0, 0, and then the next chunk is at 0, 1, and so on and so forth. So it's not the position, it's actually the grid position of the chunk, not the absolute world position. And when the player moves from one chunk to the other, I'm going to trigger generation of all the chunks around it. And if they are already there, I don't generate them. If they're not there, they're going to get generated in a thread. So each of the 8 surrounding chunks of the current chunk where the player is going to get a dedicated thread for generation. And okay, let's get started. So it's clearly complaining that I need to store the player somewhere. I have the player stored on the globals script. So what I'm going to do is I'm going to create a new script here called globals, where I'm going to store my globals. And what do I want here? I want actually to keep track of the layer for now. And I also want to store some information about the chunks and the size of the quads. And let's see, when we are ready to start, I want to store the player in our player constant. So that being said, I'm going to go to project settings, go to auto load, and I want to load this script by default when it starts, just so we are able to access this. Okay, so let's get started. First off, I'm going to create a new script. This is going to hold my chunk, or the information about one chunk. And the way I'm going to do this is it's going to extend from mesh instance. So each chunk is going to be a mesh instance. I'm going to give it a class name, chunk, just so we can reference it easily on the other script. And let's see, I need a bunch of stuff here. I'm just going to copy paste from the other project that I have opened. Basically, position is going to be the position, the absolute world position of this chunk where it starts to get generated. The grid position is going to be the position I was talking about, so 0, 0 for the center chunk and 0, 1, 0, 2, etc. For the rest. The key is going to be a string that I use to reference this chunk in the main script, just so I can keep track of which chunks I need to add or remove from our dictionary. I am going to get the noise and the material from the other script. And I'm going to store the vertices and the UVs for this particular chunk. So first thing I'm going to do is I'm going to create the init function for this class. It's going to take in the grid position where I want to generate the chunk, the noise, and the material. And then I'm just going to do like associate this, basically associate the grid position with the grid position. And I'm going to actually calculate the position, the absolute position based on this and based on the values on the globals. So the grid position x times the chunk size minus chunk size divided by 2 is going to give me where I want to start drawing this chunk. And these chunks are going to be drawn from the middle. That's why I'm subtracting here chunk size divided by 2. Next up, I want to set up the key for this chunk, which is basically a glorified name. It's the range chunk and the grid position, like 0_1 or whatever. And then I'm just going to assign the noise and the material that comes from the outside that instantiates this chunk. Now, I need to set up this material, so if I don't set up this material outside, I basically want to give it a standard stuff. Standard. I basically want to give it a standard material, and that's going to be a special material with the color white. Well, actually not white. I think this is yellow. So, other than that, I need a function to generate this chunk. Okay, so the way this generate function is going to work is I need a SurfaceTool, and now I need to generate some quads. And these quads are going to be generated based on the number of quads that I want for each chunk and based on the position that I want this chunk to be in. And the position of this chunk is going to be position.x, and then I just add x times the quad size. As it increases, it moves the quads basically by quad size, by quad size, by quad size, until we have like grid of quads in the end. So, but I still need to generate this quad. And generating this quad is going to be a function that I'm going to create next. And I'm going to come back to that function in a bit. But generating this quad is basically taking a position, absolute world position, and a size. And what this means is I need to push back a bunch of vertices. Remember that I stored the vertices array and the UVs as well. I'm just going to copy paste this because it's a bit long and I don't want to type it all. But basically what we're doing here is pushing back, creating vertices at position xy, 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 well, xz, xz, xz. Yeah, so this create vertex, I'm also going to create this function here, and this function is super simple. It basically gets, for a position x and z, I generate noise for that position. I multiply it by 3 just to have like a small increment of noise, and then I return a vector with the 3 coordinates that I want. That's basically our vertex. And then the UVs are basically just, you know, the 3 rectangles coordinates, always in the same direction, basically. And this generates a quad, or at least puts a bunch of vertices and a bunch of UVs in the respective arrays. So this means that we can now start creating some triangles based on the vertices that we generated. So I'm just going to begin using the SurfaceTool. I'm going to begin creating primitive triangles. I set the material. This is important. And then I just go through all of the vertices. And since UVs and vertices have the same number of elements in the array, I just go through the range I until vertices.size, which is going to be the same as UVs.size. And I add this to the SurfaceTool. It's important to add the UVs first. The UVs always need to be added first, otherwise you're going to get a bunch of errors. And only then add the vertices to the SurfaceTool. And then, after all of this is done, we can ask the SurfaceTool to generate the normals. And we can get a mesh from committing the SurfaceTool. This gives us a mesh. And when we have a mesh, we can basically just do assign to ourselves of all of this stuff. So I set our name just so when we add this to the tree, it gets a proper name and it's properly tracked. And I set the mesh, and I set cast shadow to 1 so that the rain also casts shadow. This is you don't need to do this. It's just I was experimenting with some stuff later, and I added this. But you can add it as well if that's okay. So I'm going to add one later You know what? I'm going to leave the collision shape for later. So our chunk is pretty much complete. It basically generates one chunk in a given position. So I suppose if I would go here and do chunk.new and ask for chunk.generate and do add child chunk, in principle I should have a chunk in the middle of our origin, and sure enough I do. And I can move. It doesn't have any collision, as you can see. I'm just going over the terrain and inside the terrain, basically. But yeah, we have a chunk, so we can generate chunks now. And the illumination looks flat shaded as well, but it's still using the yellow standard. So let's just go ahead and go to the terrain and assign our material here as well. And if we do this, we should get the same material that we have on the ball in our ground. Cool. So this is all good, but we don't have collision, and we don't have other chunks, and we don't have threading. So moving on. Instead of generating one chunk here, what I'm going to do is I am going to get the player chunk grid position, so I know where in the world, in terms of chunk grids, in terms of the chunk grid the player is. If he's going to be in 0, 0 in the beginning, but he might not if you start the game from a save game or something like that. So let's just figure out where he is in the world, and for that I need this function that I'm going to create down here, and I'm also going to copy. Let's go just like this, and then we adapt. So I need this function. This fancy weird stuff that I have here is related to the fact that I'm drawing the chunks from the middle, and I need to do these checks. Some of them might not be necessary, but I was experimenting a lot, and I kind of almost gave up on life until I got this working. But this seems to work, and this does seem to give me like the proper position in terms of grid, in terms of the chunk that the player is in, so I left it there. So after getting this, I basically need to generate the chunk at the origin, which is going to be very similar to what we just did to experiment with, passing all of this, and I'm going to create this function generate chunk, and this generate chunk function is going to be something like this. So I am passing an array, and the reason I'm passing an array is not not passing the parameters explicitly is because I'm going to reuse this function to be called from a thread, and it needs to be an array. It only accepts one argument, so that's why I'm doing it like this. And the first argument is going to be the newly instantiated chunk, but not generated. This is important. It's just instantiated. And the thread I'm running this generation in, you might notice I'm passing null here, so I'm not using any threading for the first chunk, which kind of makes sense because you load the game and there's some time to generate. I could also generate the first 8 or the first 9 like this, but I figure I just generate the first one so the player has some ground to stand in, and all the other ones can be generated by threads. So basically inside this function I'm going to ask the chunk to generate, and then I'm going to call deferred finish generating chunk with the thread and the chunk. And this means that the thread, after it finishes, it's going to call this function on the main thread, and that's where we're actually going to do stuff like the collider and all that, because apparently Godot does not like when threads start messing with things like physics and all that. So we're going to do all that, finishing and adding objects to the tree and generating collision and all that. We're going to do it on the main thread. And this function that I'm going to create here is going to do the following. So it's going to store our newly created chunk on the chunks dictionary using the chunk key, and it's going to remove it from the chunks being generated dictionary. This will make sense in a little bit. After I create another function for start generating the chunk, I add it to the chunk being generated array, but for now bear with me. And after this, I'm going to create the collider for the chunk. You know what? I'm not going to add the collider just yet. I'm just going to add the chunk to the tree with a call deferred, and I'm going to set the owner of the chunk to be this script here. So, and the reason it's using call deferred is because corta aqui. Okay, so now I just need to basically add the chunk to the tree as a child of this terrain generator node, and also set the owner of the chunk to be the terrain generated node. And now I need to do a check. If I'm not in a thread, which is the case of the first chunk that we generate, I just return. Otherwise, if I am in a thread, I want to do some cleanup. Basically, wait on the main thread, you wait for this thread to finish, which should have finished, so it should return immediately. But behind the scenes, it does some stuff to stop the thread and keep its internal state and whatnot. So we need to actually call this wait to finish for correctness. And then I'm going to find this thread on our threads array, and I'm going to remove it, basically. So it's not used anymore, there's no references to it, so Godot can just get rid of it, and we create a new one when we start to generate a new chunk. So that's all fine. This should, in principle, allow me to generate the first chunk as well. I'm going to give it a try. I'm not sure it's going to work, but I'm going to give it a try anyways. Let's see. Yeah, it does generate the first chunk again, so it's all good. So next up, we want to generate all the chunks around the first one. So I'm going to go back to the ready function, and after generating the first chunk, I'm going to create a new function that generates all the chunks around, well, the current chunk where the player is. So generate chunks around player chunk grid position, which is going to be 0, 0 in the beginning. And this function is basically going to ask for generating a bunch of chunks. And this is just references to the 8 chunks, or to the 8 grid positions around the current chunk where the player is. And we're going to call a new function called start generating function. And if you remember, there's something to do with the chunks being generated. So this function basically accepts a vector2, which is the grid position of the chunk that we want to generate, instantiates a new chunk on this grid position with the noise and the material, and checks if it's not already generated and not already generating. So if it's not, then we create a new thread. We add this chunk to the list of chunks being generated, and we start the thread with the function generate chunk, and we pass it to chunk and the thread, and we push back the thread into the threads array, just so we get a reference and we can remove it later. So that's why this generate chunk that I mentioned before accepts an array, because when you do thread.start, you need to pass it one single argument, and the way to pass multiple arguments is just to pass an array. So if all goes well, I should be able to just start this and see a bunch of other chunks being generated around us. And we do. We get like a bunch of others around us. I think the camera is clipping, so I'm going back to the player and get some more far here on the camera. And I think if I do this, I can see a lot further. Yeah, so we have all the 8 chunks around us are there now. I'm also going to do another thing. I'm going to activate visible collision shapes, because we're going to do that next. And I want to see the collision that gets generated. Actually, if we run now, we should see it around our player, at least. Yeah, so you see it there. And yeah, we're going to see the same in the terrain once we generate it. So what do we need to do now? Well, let's see. We need to detect when the player changes from one grid to the other. And so we can update and we can ask for new chunks to be generated and all that, and also clean up old chunks. So the way I'm going to do that is on the process function, which is an internal function from Godot. I am going to check where the player is, where the player was and where the player is. So, and if they are different, so if he's not in the same position he was 1 frame ago, I am going to basically generate the chunks around him, around the new position. And yeah, let's do that. So I don't clean up yet, just so you see something. And if I run this, as I move, I should see new chunks being generated. So I'm not going to move out of the blue stuff, otherwise I would fall down. But you can see that it's being generated, but it's not being cleaned up. So I'm here, and there are a bunch of them that should have been cleaned up by now. So what I need to do this is I'm just going to call deferred clean up old chunks after we generate, and this function is basically going to, well, clean up old chunks. And it's a bit archaic the way I did this function. I don't really like it. It's not my best work, but it works. So I left a 7 hanging there, but it works. And so I basically keep track of what I consider to be valid chunks, which are going to be like the center, the current position where the player is, the center, plus all the other 8 chunks around. And I store some keys in an array of valid chunks. And then I'm going to try to see which keys I need to erase from the current existing ones. So if I go through all the keys in the current chunks I'm keeping track, and if all the ones that are not in these valid chunks get pushed back into these keys to erase, and then I just go through all these keys to erase, and I delete them from the chunks, and I delete them from the tree as well with Q free. And this should make sure that as I move throughout the terrain, if I move backwards, so yeah, you see, all of the other ones, the other chunks that get left behind, they get deleted. And this ensures that I only have, at any given point, I only have like 9 chunks being drawn, which is pretty cool. Okay, so what do we need now? We are cleaning up, so we just need basically our collision shape, just so we can walk on top of our terrain. And how do we do this? Well, I left on the chunk. Oh, I don't have it here yet. Okay, so we need a new function on the chunk to generate a collider. And since we already generated all the vertices from the mesh, we can reuse those vertices to generate a collider. So I'm just going to add a function here called create collider. And this is going to create a concave polygon shape based on the vertices that we already created before. Then it creates a collision shape with that particular shape, adds a static body with that shape as well, and sets some collision layering and masking, which I actually need to change, that I didn't change yet. And then adds to this chunk, or to the mesh instance, it adds the static body. So it should all just work as long as we call this create collider. And we're going to create this create collider on the main thread after the chunk is done generating, just because the physics engine doesn't like multi-threading for now. But first, I'm going to the project settings, and I'm going to the, let's see, what do I want? 3D physics? Yes. So this is going to be the terrain layer, and this is going to be the player layer here. And I'm just going to go to the scene, the player collision. It should have player, and doesn't interact with other players, but does interact with the terrain. And it should be fine also for the terrain, because I do set it correctly, I think. So it is on the terrain, and 2 means that it interacts with player but not with any of the other ones, the collision mask. It should be fine. We'll just see if it is or not. So now in the terrain generator, we can just go back to, let's see what we want to do this. I think we want to do this on the finish generating thread, if I'm not mistaken. So as soon as the chunk finishes generating, before we add it to the tree, we're just going to create the collider. And this should make sure that we get a proper collision shape on our terrain. There you go. You see from the debug flag that we set for the editor, we can see the collision. And now we are actually traveling on top of the terrain. You should be able to see the player climbing and going down. And yeah, seems to be working. So yeah, that's it. I hope you enjoyed this tutorial. I hope it was fun for you, and I hope you learned something. It took me a while to get all this right, especially because of the multi-threading thing. Things kept crashing and all chaotic, but in the end it all goes well. So I'm pretty happy with how it turned out. Yeah, I hope you enjoyed. Consider subscribing, and talk to you later.